CAT 21 slot 1 question 13. The number of groups of 3 or more distinct numbers that can be chosen from 1, 2, 3, 4, 5, 6, 7, 8, so that the groups always include 3 and 5 while 7 and 8 are never included together is how many? So that's a combinatorics question. You have to select 3 or more. You don't know the exact number number of items you have to select, but there is a lower limit of 3, out of which 3 and 5 always included, which means we can actually remove that from the problem and solve for the rest. 3 and 5 are always included, so that's 2 of the minimum 3, which means out of the remaining 6 I have to select at least one more. That's one condition. The other condition is that you can either select 7 or 8, or you can select neither. They can't be included together, but they can be excluded simultaneously. So either you'll have one or the other or neither, and you have to select at least one item from the remaining 6 items. So if you look at the tags, you will see FTC, which is not fundamental theory, which is fundamental theory of counting. It is not absolutely necessary. The other tag given is partition, which is creating mutually exclusive and collectively exhaustive cases. You can do it with 2 cases and invoke FTC in one of the 2 cases, or you can simply just do it in 3 cases. The other thing I've mentioned is knowing that the sum of binomial coefficients is equal to 2 raised to n will speed up this process. So let's see what happens. So you can say because of the ambiguity about 7 or 8, there are 2 different things that can happen. One is that you are not taking anything from them. The other is you are taking one of the 2. So that's 2 cases, and these 2 cases will play out differently. So case 1, select either 7 or 8. Now notice that this will take care of the third item that has to be selected. You have selected 3, you have selected 5, now you're selecting 7 or 8. So that takes care of the minimum of 3 that should be selected, which means out of the remaining 4, you can select as many as all 4 of them, or you can select none or reject all 4, which means this can be done in how many ways? You can select 0, or you can select 1, or you can select 2, or you can select 3 of the 4, or 3 of the 4, or you can select all 4. This is not the entire case 1. There is a part before that. You have to select either 7 or 8. So that's 2 choices, right? You can either select 7 or you can select 8, 2 choices, independent of which, as far as 1, 2, 4, 6 are concerned, you can select none, or you can select all, or you can select anything in between. So that's 4C0 plus 4C1 plus 4C2 plus 4C3 plus 4C4. Based on this result, you can just say that this is equal to 2 raised to 4, right? So this is going to be 2 into 2 raised to 4, which is 2 into 16, which is 32. This is case 1, and this is the bit where you use FTC, fundamental theory of counting. Then you have case 2, which is slightly different, which is that you have to reject both 7 and 8. Now in this case, you have to select at least one item out of 1, 2, 3, 4. Then only will you satisfy the condition at the beginning where you have to select at least 3 items. That means you have to select either one item or 2 items or 3 items or all 4 items from the available 4 items 1, 2, 4 and 6. Now this is almost identical to the previous expression, except that is missing the first term, and we know that the first term is equal to 1, so it's going to be 1 less than what this was. This was 16. We know that this was 16. If you remove this 1 from that, the rest will add up to 15, and that's case 2. So this case 1 and case 2 together account for all the possibilities. These two cases are mutually exclusive and collectively exhaustive. That is why partition is relevant. And then for calculating case 1, we had two independent steps there. First step is choosing which one out of 7 or 8 will select, and step 2 was select as many or as few items as you want from 1 to 4 6. That was the FTC part. And to get the value in that sum expression, this would save you some time. Sum of binomial coefficients is equal to 2 raised to n. So that's all you have in this question. We have two cases, MECE. Add them up, 32 plus 15, 47 is your answer. Let's look at question 14. A circle of diameter 8 inches is inscribed in a triangle ABC where angle ABC is 90 degrees. If BC is 10, then the area of the triangle in square inches is what? What are the tags I have? Okay, you can do this rigorously or you can bypass it using Pythagorean triples. Let's see how this looks like. So we have a right triangle and we have a circle inside. This right triangle is ABC, right angle at B. What we know is that, okay, B is 90, that's fine. BC is 10. We know that BC is 10. And the diameter of the circle is 8 inches, which is an indirect way of saying that the radius is 4. We need to find the area of the triangle in square inches. So this is an inscribed circle in a right angle triangle. There are some results there. What are the tags I've given? We have just two tags: circle tangent properties, which is the idea that two tangents to the same circle from the same external point have the same length. That's one of the many circle tangent properties, but that's the one that we are interested in as far as this question is concerned. Two tangents to a circle from the same external point are equal in length. The other concept we need obviously is triangle area formula, which we can do in many ways. Here I think the easiest thing to do is to find AB and BC. BC we already have. We find AB and then we do half into base into height. That is what we need to do. I've also mentioned Pythagorean triples. Let's see how that's relevant. Now, because the diameter is 8 inches, we have found that the radius is 4. Usually these questions play out in the same way, which is if this is 4, then this is all okay. So basically, since this would create a square, understand that these lines are already perpendicular. This radius is perpendicular to this tangent, this radius is perpendicular to this tangent. So basically all four angles here are 90. On top of that we have, so that makes it a rectangle. On top of that we have two adjacent sides are equal in length, which now makes it a square. So all of this is 4, all four sides are 4, and we have horizontal lines and vertical lines the way that I've drawn this. Now what we can do is you can say that this is x. Let's scratch that. We know that BC is 10, so we can take this as 6. Now based on the tangent property that I mentioned, this portion is also going to be 6, and what you can do is you can say that this is x and this is x. Those two are going to be equal to each other as well. And then we can write the Pythagoras theorem, which is that the square of the hypotenuse. I guess I should add that. That should be a tag. Pythagoras theorem, square of the hypotenuse is equal to the sum of the squares of the other two sides. So we will have x plus 6 whole square. I'm doing the rigorous approach first. We'll talk about optimizations after. So we have x plus 6 the whole square is equal to x plus 4 whole square plus 10 square. Now this looks like a quadratic, but notice that the x square coefficient is 1 on the LHS and the RHS. They will cancel and it will reduce to a linear equation. X square plus 12x plus 36 is equal to x square plus 8x plus 16 plus 100. X squares will cancel. Isolate the x terms in this side, 4x. The other side would be 100 plus 16 minus 36, which is 100 minus 20, which is 80. X is 20. Now we know that the vertical side AB is 24. We already had BC is equal to 10, so the area is going to be half into 24 into 10, which is 120. Okay, so one concept that's worth mentioning, Pythagoras theorem, obviously very frequently tested in CAT Quant. Now, what are the optimizations? There are a couple. One is to just ask yourself, you have to identify this first. You have to identify that because the 10 is split as 4 and 6, you will have a 4 and a 6 here, and you will have an x and an x here, which means that the hypotenuse is 2 more than the first side. Let's call it the first side. So we have a situation where hypotenuse is side 1 plus 2 and side 2 is equal to 10. Now if you ask yourself, can you recall a primitive Pythagorean triple or a multiple of a primitive Pythagorean triple where the smallest side is 10 and the other two sides differ by 2? You might think of the double of 13, 12, 5, which is 26, 24, 10. And if you do that, you would have bypassed the rigorous solution and you would have gotten the 24, and the rest is the same. You can find area using half BH. Yeah, that's it. That's the optimization. Pythagorean most questions, competitive exam questions built around right triangles will use the common Pythagorean triples. Just learn the first few primitive Pythagorean triples and use their multiples. You might see that the question is based on one of them, and it will help you bypass the rigorous algebra that enables us to find the sides. So that's question 14. Let's look at question 15. What are the tags? Just the two tags, I guess. Okay, suppose the length of each side of a regular hexagon ABCDEF is 2 centimeter. If T is the midpoint of CD, then the length of AT is how much? We have options. So we have a regular hexagon A, B, C, D, E, F. Sides are 2. T is the midpoint of CD. We are interested in the length AT. Pretty conceptual question, not much in terms of optimization. We know that each angle of this regular hexagon is 120 degrees. So what I want here is a construction AC. What does it give us? We get a triangle ABC, which we should be familiar with. ABC is a 30, 30, 120 triangle, and you should know by heart, if you're a serious CAT aspirant, that this will have sides in the ratio 1:1:√3. This is the optimizable bit here. If you know this by heart, standard triangle ratio, there are a few triangles like this. The 45, 45 90 triangle, for example, isosceles right triangle, has 1 is to 1 is to root 2. The 60 60 60 obviously is a equilateral triangle, 1 is to 1 is to 1. There is the 30 60 90, which is 1 is to root 3 is to 2. These are examples. These are most of the examples, right? You should know this by heart. Now, that means that if this is 2, AB is 2 and BC is 2, we have AC is 2 root 3 based on this ratio. Now, we look at the triangle ACT and we know that angle B of the angle C of the hexagon is 120, but we also know that this much angle ACB is 30, which means that you will get a 90 here, and it's a right triangle. Now we know that DC, like every other side, is 2, and since T is the midpoint, TC is going to be 1. So now we have a right triangle where the legs are 2 root 3 and 1. So AT, again by Pythagoras, AT square would be 2 root 3 squared plus 1 squared, which should be 12 plus 1 13, and AT would be root 13. I feel I've glozed over the first part of this. I did not explain how it is 30 30 120. Here's what happens. We already know that angles of a regular hexagon are 120, and we know that because it's a hexagon, AB is equal to BC. So by angle sum property, the remaining 60 after 120, there's a remaining 60 degrees in this triangle. Because of the isosceles nature of this triangle, you will have to split it evenly as 30 30. That's how we get the initial 30 30 120 angles, which gives us the 1 is to 1 is to root 3 ratio. And afterwards, the rest of it is whatever I've just mentioned now. Knowing this is the most impactful in terms of reducing your time consumption. Okay, let's move on to question 16. Question 16. Suppose hospital A admitted 21 fewer COVID infected patients than hospital B, and all eventually recovered. The sum of recovery days for patients in hospitals A and B were 200 and 152 respectively. If the average recovery days for patients admitted in hospital A was 3 more than the average in hospital B, then the number admitted in hospital A was how many? It's question 16. Just the one tag I've given, probably more is there. Word problem quadratic, what could speed up your solution is being able to factorize a quadratic quickly. That is kind of obvious. But let's look at the question. How do you frame this? The word problem part is probably what prevents you from solving. Solving the quadratic should be easy after. Now, we know that A admitted 21 fewer patients than B. Total number of recovery days is 200 and 152. The difference in the average is given. So if A had X patients, then B would have X plus 21. The average days, recovery days for patients in A would be the 200 total days divided by the X patients, and the corresponding value for B would be total of 152 days for the X plus 21 patients. Those are the expressions you frame from the one variable that you have defined, and then there is the information that helps us put these expressions into an equation. The average for A was 3 more than the average for B. So the average for A, this expression right here, is 3 more than the average for B. Now we have an equation which has X and X plus 21 in the denominators of the two terms. Now by the time you simplify this, this will become a quadratic equation. If you want to bypass a couple of steps and execute the solution faster, I would just say multiply both sides by X into X plus 21. Multiply both sides by X into X plus 21, which will give you on the LHS 200 into X plus 21, 200X plus 4200. The first term on the RHS becomes 152 into x, and the second term becomes 3 into x plus 21, which is 3x square plus 63x. Now you want to make this into a standard quadratic form. That's 3x square. What about the x terms? Yeah, I tend to do subtractions first to give me smaller values, intermediate values. So 152 minus 200 is minus 48, plus 63 is plus 15, plus 15x, and then the 4200 comes to the other side, becomes minus 4200. You want to simplify this, take out the 3, x square plus 5x minus 1400 is equal to 0. And I've mentioned uh, factorizing quadratics where the square term coefficient is 1 is pretty easy. If you have a negative, you want to take a difference of 5 instead of a sum of 5 along with the product of 1400. Ignore the sign, find the magnitudes of the split, and then use the signs appropriately. So what does that look like? I'm thinking of two numbers with a difference of 5 and the product of 1400. They are 35 and 40. Now because we have a plus 5, I would say x square plus 40 x minus 35x minus 1400, and you can simplify this and you'll get x is equal to 35. Now again, with a little bit of practice, you'll get to a point where you will say plus 5 is split as 40 and 35. Because it's plus 5, it's going to be a plus 40 and a minus 35, and as soon as you say that, you will say that the valid root is 35. Clearly the number of patients cannot be minus 40. It can only be plus 35. And you don't need to write all the steps and put it into a, x plus 40 into x minus 35 is equal to 0, therefore x is equal to minus 40 or plus 35. You don't have to write all the steps. You know exactly how it's going to pan out, so you could skip a few steps of writing there. So we have x is equal to 35. The number of the number of patients admitted to hospital A is what they're asking, which is our assumed x itself, so it should be 35, and that is the answer. Not much in terms of optimization. This general rule with the difference and product should help, because you can find the split without involving the signs, and after you find the two numbers you can use the signs accordingly. That should help a bit. Other than that, not much in terms of optimization. So that's question 16. Let's look at question 17. Question 17. The amount Neeta and Geeta together earn in a day equals what Sita alone earns in 6 days. We can just straight up write an equation for that, saying n plus g is equal to 6s. Clearly the variables stand for their daily earnings. And the next equation, the amount Sita and Neeta together earn in a day equals what Geeta alone earns in 2 days. The ratio of the daily earnings of the one who earns the most to that of the one who earns the least. They're asking about the highest earning versus lowest earning ratio, not the actual values. Now this basically calls back to something I mentioned with one of the earlier questions. This one, the question 5, where I mentioned that if you have one equation fewer than the number of unknowns, clearly it is not resolvable in terms of finding the values, but you can still find the ratio of the values. The same thing is happening here. You have three variables n, g and s, and you have only two equations, so it is not possible to resolve n, g and s. You cannot find the exact values, but you can find n is to g is to s. You should be aware of the fact that you can resolve the ratio of n terms in using n minus 1 equations. So you can find this, and then we don't know who's going to be the biggest earner and who's going to be the smallest earner. After we find the three numbers, we take the biggest number and the smallest number and put them together into a ratio of 2 terms. That should be the answer. Now, how do you go about doing this? There are many ways of doing this. Based on the actual coefficients involved, I would say the easiest thing is to make n the subject in both equations. So you have n is equal to 6s minus g from the first equation, but is also equal to 2g minus s from the second equation. I'll ignore this part. Let's isolate the g's and the s's. You get 3g on the one side and you get 7s on the other side. At this point, to find the ratio, I would simply suggest putting g is equal to 7 and s is equal to 3. Easiest way to balance an equation like this and find the ratio is to use the inverse terms, because 7 into 3 is going to be equal to 3 into 7. Now we'll put that here. S is equal to 3, g is equal to 7, and then you can substitute these numbers in either of these equations to find the corresponding term for n in this ratio. Please remember that these are not the actual earnings, just getting us the ratio of the earnings. If you want to do this in a more rigorous way, the kind of approach that you used to do in school, you would have said let g is equal to 7k and s is equal to 3k, and you will get n is equal to something k, and then we'll say as a result of it the ratio is whatever this number is to 7 is to 3. We don't have to bother with that k because we're trying to optimize for fewer steps and faster solutions. So we just have the 7 and the 3. Now if you put g is equal to 7 and s is equal to 3, you should get n is equal to 11, giving us a final ratio of 11 is to 7 is to 3, and an answer of 11 is to 3, if I'm not mistaken, it is 11 is to 3. So that is the 17th question. What concepts? I have tagged unknown ratio with an additional comment of 2 equations and 3 variables. That's all I've given. It's really just algebraic simplification. You strictly don't need to know this concept or be able to state it to solve this question. All you need to know is you simplify by equating equal things. Here I wrote the same n in 2 different ways, and then clearly I can equate them, and you keep simplifying based on that and you get the ratio. So that's question 17. Let's look at the last question of this video, 18. The natural numbers are divided into groups as 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. Then the sum of the numbers in the 15th group is equal to. So this requires some pattern recognition. Which I've mentioned here. What else? AP, yeah, it's a progressions question. So let's see what's happening in the pattern here. You have 1 sitting as a single group, and then you have 2, 3, 4, and then you have 5, 6, 7, 8, 9. It's clear what's happening. You end at n square terms, right? You can also interpret it as 1 term, 3 term, 5 terms, and the next should be 7 terms. Or you can say it ends at a square number. So the next, either way you look at it, the next one will be 10, 11, 12, 13, 14, 15, 16, and the next will be 17 to 25 and so on. So the fourth group ends at 4 square. The third group ends at 3 square. Where does it start? It starts after 2 square, right? So that's enough for us to get going with this question. Now, what is the formula for the sum? We know that these are all APs. Consecutive numbers are going to be an AP, and we have a formula for sum of an AP, which is the general formula is average into number of terms, which is true for any group of numbers. But then as far as the AP side of things is concerned, you can say that the average is going to be the first term plus the last term by 2. Average of an AP is the average of the first and last terms into number of terms. So let's find out what these are. Let's take the third group as an example. Just use an example and understand the pattern, and then go from there. Notice that the third group is 5 terms, second group is 3 terms, first group is 1 term, fourth group is 7 terms. So the number of terms is increasing by 2. So it's going to be 2n plus or minus something. Think about it. And here It is the third group, so n is 3. 2 into 3 is 6, but we have only 5, so it's 2 into 3 minus 1. Here it is second group, 2 into 2, but that's 4. We need only 3, that's minus 1. This is 2 into 1 minus 1, number of terms. So the general formula for that would be 2 into n minus 1. That is what you'll notice. So this part is 2n minus 1. What is the first part? We have the last term of a group is very obvious. We mentioned this already. It's just going to be n square. Third group ends in 3 square. Fourth group ends in 4 square, and so on. So the last term is just n square. What about the first term? The first term is the number immediately after the previous square. So that's going to be n minus 1 square plus 1. The previous group ended with n minus 1 square, and the current group begins with 1 more than that. So it is n minus 1 whole square plus 1 as the first term, and then n square as the last term, and then you have to divide by 2. So now you have an expression for the average, and now you have an expression for the number of terms. I'll simplify this a little bit. Let's write one more row here. This gives you n square minus 2n plus 1 plus 1 plus n square by 2 into 2n minus 1. Now you'll notice that there are 2 n square terms, there's a 2n, there are 2 1 terms. When you simplify this, what happens? You get n square minus n plus 1 into 2n minus 1. That's the expression. Let's just write it properly. Sum is equal to sum of the terms in the nth group is equal to n square minus n plus 1 into 2n minus 1. Now we need to find the value for the 15th group. So substitute n is equal to 15. So a few simple calculation optimizations here. Instead of finding 15 square minus 15, that's actually fine. 15 square is 225, minus 15 is 210, plus 1 is 211. And then 2 into 15 minus 1 is 29. At this point, don't do this calculation. Notice that it should end in 9. There's only one option out of the 4 that ends in 9, and that's 609. That should be the answer. So you can exploit the given options, eliminate the last 3, and say that the first one was correct. So a bit of pattern recognition and some concepts from just the one concept from AP. Average is first plus last term by 2, and the general average sum from average formula.